All right, well, I'll get started here. You guys ready for the weekend? Yeah, I know I am. So let me begin with a word of prayer. No. Heavenly Father, we thank you for this day. Thank you for these students. Again, I just pray you'd guide our work today, help us to glorify you in what we do, and we just pray, Lord, that we would appreciate the beauty of your creation each day, and just your love for us, Lord. In your name I pray. Amen. Okay, so any questions? Oh, you don't have to follow me around. It's all good. I mean, you can, but let's see here. If there are no particular questions, let me just dive into some problems in the homework which are similar to things we've done before, but not quite the same pattern. All right, so like here's one. 5x squared plus 17x less than or equal to 12. Now this one is it's what's up with like the people who like clean the floor in here or something? They're like trying to like pin me to the board or something with you guys. It's too late. I should just like, I'm sorry if I end up spitting on you at some point, or I don't know. I want to try not to. I don't usually. I mean, I'm not like a baseball player or something. I don't feel the need to compulsively spit while I work, but you guys are fine. So let me stop distracting the class. Here we go. So how do you solve this problem? What have we studied? We've studied how to solve inequalities where we have less than or greater than 0, right? We need to make it look like that. So that's pretty much going to be the story for the first like 4 examples today. We're going to have something which doesn't fit the pattern we had before this week, and we're just going to make it conform to the pattern we already saw. And once we do that, then we can use the techniques we talked about earlier this week. All right, so like here, subtract 12 to the other side, right? So we've got 5x squared plus 17x minus 12 less than or equal to 0. Now, because this is a homework problem, I'm pretty sure you can factor it. Let's see if we can figure it out. So we've got 5x, x, right? And then we're looking for something that multiplies to 12, right? How do you multiply to 12? 1 times 12, 2 times 6, 3 times 4, right? These are the kind of numbers you're going to be putting here and here, right? Either 1 and 12, 2 and 6, or 3 and 4, or the opposite around. We need to get a 17. How do we make that happen? A 4 and a 3. So I do plus 4 minus 3. Oh, that didn't work, did it? See what, like that gives us what? This gives us minus 15 plus 4. That'd be minus 11 in the middle. So do we give up? No, we try again. So just flip the 4 and the 3. Now we've got minus 20x plus 3. Oh man, we got minus 17x. Did it work? Almost. It's a trap. So notice we got plus 3x minus 20. That's still not what we want because we want to get 17. So we need to flip the signs here. Minus, plus, all right. So anyway, there it is. You can factor that. It's not the easiest factoring problem in the world, but it is one you can do. Now what? Now we fall back on our 4-step program, right? Identify the critical points, draw the number line, test the points, write down the answer. So here, what are the critical numbers? Yeah, negative 4. Right, so the way, let me just, since we haven't run up against this yet, they're going to be solutions to 5x minus 3 equals to 0 and x plus 4 equal to 0. I didn't need to write that down before because we could just, like this one, we could just see, oh, it's x equals minus 4, right? But this one, maybe you have to solve, so you get x equals 2, add 3 to the other side, divide by 5, right? So you get 3/5. So those are my critical numbers. right? Now I draw a number line, like so. Which one comes first, -4 or 3/5? -4, very good. Then the 3/5 over here. Now we need to test a point to decide the polarity, the plus or minus in each region, right? And so what you got? Where would you suggest I check? Let's check 0. Where is 0 in this story? In the middle. Yeah, between the minus and the plus. So 0 is up in here. Plug in 0, what do you get? This is the easiest formula to use. You get -12. So it's negative in the middle. Sign flip theorem says that we're going to change signs from minus to plus on either side because we've got to the power 1 here and to the power 1 here. So I just go pluses, pluses. All right, so that's step 3 of our 3-step process. Now we can read the answer. What's the answer? Solution set. What is it? Do I include or exclude -4 here? I include because we're looking for either is less than or equals to 0. Equals to 0 is allowed, so we include 4. And then union, include 3/5 for the same reason to infinity. There you go. Answer. This is like, roughly speaking, number 8 in your homework, all right? Is that one of yours?
Apparently. I don't remember putting it over there, but I might have.
If you see something, say something. This could be a bomb.
My bad.
I mean, you don't know.
I'm really sorry. I can come move it if you want.
No, it's yours?
Yeah.
Oh, okay, okay.
Yeah.
Not a bomb, right?
Yeah, not a
Okay,
problem.
okay. Yeah. It's good, it's good. All right. Although you do have to wonder, has a bombing ever been stopped by asking the bomber, is it a bomb? Does that ever work? I don't know. Oh, what? Only, what's that?
It's like, you got me.
It's like, you got me.
The hands are in the air, you got me.
I mean, my experience, when I have caught students cheating, all right, like just obviously cheating, all right, like it's just clear. They will look at you in your face, like this far, eyes meeting, and say, no, I didn't cheat. I didn't do it. I didn't cheat, no. Like, people lie. Not everybody, but I mean, I don't lie. You can trust me, right? But if I tell you that, and I'm the source of that, it does beg the question, doesn't it? Let's see here, x minus 5 over x minus 4. I like this problem. This problem is really easy. So this actually I shouldn't even cover today. I should focus on harder problems today. But we'll do this one just as a break from the harder ones. So what are the critical numbers here? Critical number, positive 5 and positive 4, right? Oh, I should mention, this is numbers. If you thought I've been like hashtagging something all along, that would be incorrect. There are no hashtags in this class. Let's see here. We used to call it pound. So anyway, okay, so a number line. So there's step 2. Actually, this is step 1, right? I can't remember my steps. Oh well, anyway, here we go. Draw the, which comes first, 4 or 5? 4, 5, right? Now if you want to plug in, you plug in whatever you want, but be careful, make sure you put the test point where it belongs. Like, so here, I think I would plug in, I don't know, 3. You can plug in 0 if you want. Where's 0? Yeah, 0's over here somewhere, right? Not to scale, obviously. Plugging in 0, what do we get? 0 minus 5 over 0 minus 4. Yeah, which is negative 5 over 4, which is 5/4. That's positive, right? So for that reason, we put pluses up here, right? when the expression is a fraction or something, sometimes it pays off to just write it down to be sure you tested the point correctly. It is important that you test the point carefully, because everything else after that is wrong if you're wrong on that, you know. But anyway, so here, 4 and 5 are both appearing with linear factors like x minus 5, x minus 4. So the power of the factor is 1, which is odd, so I do sign flips. So I flip plus to minus, and minus to plus again. What's my solution? Less than or equal to 0, right? So I need to go just the middle region, right? 4 to 5. Now my question to you is, which one of those do I need to include? Both? Neither? Which one do I include? Which one do I exclude? Include what? Include the 5? I'll agree with that. If we plug in 5, the expression makes sense. It's 0 over 1. 0 over 1 is just 0. 0 is less than or equal to 0. That's good. 5 is in the solution set, sure. How about 4? Yeah, 4 we cannot do. 4 is division by 0 for this expression. So we must exclude 4, like that. There you go. That's, I think, roughly number 9. No, excuse me, that's not, well, what is that? Number 11, your homework is roughly that. All right, let me show you how to work something like number 12 in your homework. Yep.
Would the solution set of the first example be correct because we're going for less than or equal to 0? So if you plug in negative 5, it would be 28, which is greater than
Oh, did I? Oh my! Why you guys gotta stop me? Like, this is not just wrong. It's like the most possible. It's like, well, it's almost entirely wrong, right? There's only 2 numbers in this whole solution set which are legit, right? The only thing that's legit here are the minus 4 and the 3/5. Look, we were solving less than or equal to, right? Which means I was supposed to be looking for the minuses. Yeah? I solved greater. This is the solution to greater than or equal to. So we've solved. This is 5x squared plus 17x greater than or equal to 12. That's the solution to this, okay? The solution to the problem which is stated is just minus 4 to 3/5. Thank you. Very good question. Thanks, sir. The rest of you, come on.
I'm not gonna lie.
You're not gonna lie, what?
I'm not gonna lie, I didn't notice because I'm also learning.
You're also learning? Yeah. I'm just too close to the board. So, I mean, I'd like to say I can learn my way out of doing that again, but it's just not the case. Like, I do completely and entirely understand this method, and yet I still make that mistake, right? Yeah.
Why do you know they're different though? 'Cause, like,
Okay, so, go on.
'cause I thought you just solve for a point and then depending on if like the center was minus, then that would mean that it's not included.
It depends on the inequality. If we're solving a less than problem,
You're looking for minus?
looking for minuses. If we're solving greater than 0, we're looking for pluses.
Okay.
So it's because we're working relative to 0. Either you're to the right of 0 or to the left of 0. Yeah.
How did, okay, so my question is for the between the 4 and the 5.
Yeah.
How did you know which one to include? You explained a bit and I didn't get it.
Okay, so I can talk through it again. So the reason that we've included 5, right, is because that corresponds to the numerator being 0. When we plug in x equal to 5, we get 5 minus 5, which is 0, over 5 minus 4, which is 1. So 0 over 1 is what we get when we plug in 5. That's fine. 0 over 1 is just 0. That's allowed. Is 0 equal to 0? Sure it is, right? That's in the solution set. 4, on the other hand, when we plug 4 into this expression, we get minus 1 over 0. Minus 1 over 0 is just undefined, right? So it doesn't give us less than, it doesn't give us 0. It satisfies neither of the necessary conditions to be in the solution set here, and as such, we have to exclude it from the solution set. So, in short, the difference is one's from the numerator, one's from the denominator. So that's the difference. still learning. You can't still be learning. The reason you take classes is to show people that you already know the things that you're taking the class on, right? I mean, you think classes are for learning? Okay, thanks. That's probably true. No, that's why I don't always expect you guys to answer my questions. I ask questions because they're questions that you should be trying to answer. If you can't answer the questions as I ask them, that's okay. I mean, hopefully if after the dust settles and you're near the next test and you go back and rewatch a lecture or something that we've done and you see the question that I asked, you could answer it then, you know, maybe. If it's not some sort of rhetorical, political inside joke or something, you know. But I try to keep those to a minimum. Temptation to say rhetorical inside joke, very strong at the moment. Must resist. Okay, so here we go. How do you solve this one? This, by the way, yep.
Could you multiply, could you like put x minus 6 plus 1?
Ooh, so you're asking, couldn't we just multiply by x plus 6? You could, but then that opens a certain can of worms, right? Because the question is, if you multiply by x plus 6, is it positive or is it negative? See, because after you multiply by x plus 6, you have now devoted yourself to a two-part choose-your-own-adventure story. The one path is x plus 6 is positive. The other path is x plus 6 is negative. If x plus 6 is positive, when you multiply by x plus 6, you maintain the inequality. If x plus 6 is negative, then you have to switch that less than or equal to a greater than or equal to. And then you have to look at those two problems and work them out.
Yeah.
Yeah. Or we could do this. So minus 2. And see, if we do that, then we can just be boring and do it the same way as example 2, make our number line. Now we have to do some work, right? We have to make a common denominator. How do we do that? Like this, right? So make a common denominator of x plus 6. All of this is still less than or equal to 0. Clean it up. What do we have? Oh, this gives us a minus 12 plus 12, right? So what we're looking at here is minus 2x over x plus 6. All right, so at this point, we have done the algebra we need to recast it as one of the problems we solved Monday or Wednesday, right? Now we can fall back on our four-step program, yeah? So really the first step of the program in some sense is making sure the problem's the right type. And it is a fact that all of the problems in your homework you can recast to look like this. Like any of the inequalities that you're faced with, you can rearrange them so that it's less than or equal to 0 or greater than or equal to 0. You always have this freedom. Now I could go down the path that you were suggesting and like try that out if you want me to, but I do think this is faster and you're less likely to make mistakes.
Okay.
Like I would recommend doing it the way I'm doing it. Let's see here. So, oh, I'm sorry, I forgot. What are the critical numbers? I'm supposed to state those, right? Critical numbers are? I heard 0 and I heard what? Negative 6. Yeah. 0 and negative 6 are the critical numbers. 0 makes the numerator 0. Minus 6 makes the denominator 0. That means that 0 could be included in the solution set, but minus 6 will not be in the solution set because it's division by 0. All right. So we plug in, which one comes first? Minus 6 comes first. 0 comes second, right? Now this problem, you can't plug in 0 for your test point because it is one of the critical numbers, right? You have to plug in points between the critical numbers for test points. I heard a negative 1. I heard a 1. We'll take a vote. Who wants to do minus 1? All right. Who wants to do 1? Sorry, minus 1s have it. I was kind of hoping the 1s would win. Oh well. Plug in minus 1. What do you get? I'll do it down here. Minus 2 times minus 1 over minus 1 plus 6. What do we get? Well, that's 2. Minus 2 times 2. Minus 2 times minus 1 is 2. Yeah? Multiplication there. 2 over 5. So the key is it's positive, right? So we get positive pluses up in here. And again, both of the factors that we're dealing with, neither of them is repeated. They're both linear, they're both odd, so we do sign flips. Sign flips both here and over here. All right, now I should be careful. Are we solving less than or equal to 0 or greater than or equal to 0? That's what's less than, so I should be looking for the negatives. So what's the solution here? Solution set. Minus infinity to minus 6, unioned with 0 to positive infinity. Now, which one do I include? Which one do I exclude here? We include 0 because that gives us 0 in the numerator, because there's an x in the numerator. We exclude minus 6 because x plus 6 is in the denominator. All right? There you go. Solution.
Why did you exclude negative 6?
I excluded negative 6 because if we plug negative 6 into this, we get division by 0 here. Is good? All right. Yeah? Huh?
Oh, no.
Do you want me to try the other way?
Yeah, I've been only doing the other way.
Oh, okay. Well, I mean,
It's my own fault, though.
no. That's fine. As long as you you know. I mean, you're not wrong. So if x plus 6 is positive, right? Then we get 12 is less than or equal to 2 times x plus 6, right? So that means what? X is greater than minus 6. And what else here? 12 is less than or equal to 2x plus 12, which means what? 0 is less than or equal to 2x. 0 is less than or equal to x. So you look at what you got. You've got what? X greater than minus 6 and x less than or equal to 0. Can you, I mean, that puts x where? X is an element of, wait a minute, x is, excuse me, x is what? Greater than or equal to 0? Wait a minute. We have x greater than or equal to 0, and we have x greater than minus 6. So when you look at these two, which one of them wins? I mean, we're saying if this holds, we need to solve this. We work this out. We get x is greater than or equal to 0. Can you have that in the universe of ideas where x is greater than minus 6? I mean, you can, right? If x is greater than or equal to 0, it's greater than minus 6. But this is now irrelevant, right? So this part of the storyline says that x is an element of 0 to infinity, right? And the x greater than minus 6 has got nothing to do with it. So that was case 1. The other case, though, is x plus 6 less than 0, right? And if x plus 6 is less than 0, then we have 12 over x plus 6 times x plus 6 is greater than or equal to 2 times x plus 6. See, I have to flip the inequality if I multiply by that, right? And then these cancel, and we get 12 is greater than or equal to 2x plus 12, right? And then we get 0 is greater than or equal to 2x, which again gives us that 0 is greater than or equal to x, aka x is less than or equal to 0, right? But this is all done under the, this calculation in black is all done under the presupposition that we're in case number 2. What's case number 2 say? It says this right here, right? What does that say? That says x is less than minus 6, right? So you're only permitted to do these calculations if you're under this assumption, which means while though you have the appearance of x less than or equal to 0 as the solution here, it's not actually the case, right? This actually says then, okay, x is an element of, minus infinity to minus 6. Because the initial assumption is the one that is dominant here. So you have to always be thinking about the balance between your choice and what the outcome of working out the inequality is, and which one takes precedence in that case. This requires thinking. This requires no thinking. We want no thinking, right?
Yeah, I think I'm just going to use the other
Well, no thinking is too, you're like, no thinking, I don't understand it. How dare you, you jerk. This requires less thinking. Let's say less thinking. Those are kinder words, yes. Mm-hmm.
Why do you have 2/5 is greater than 0? Where'd you get the greater than sign from?
Because 2/5 is greater than 0. I don't know.
Bigger than 0?
2/5 is greater than 0 though, right?
No, it is. I just.
Oh, where did I get it? Oh,
Why you wrote that.
oh, why I wrote that. Okay, I got you. Now I got you. I understand. I'm testing this point right here, right? So if it's greater than 0, I put pluses. If it's less than 0, I put minuses. So I'm saying greater than 0, so this tells me write pluses. That's all. Okay. Sorry, you see, I understand the question you're asking. I was thinking you were asking a much more basic question, like, how do I know 2/5 is positive? And like, I don't know how to answer that actually,
I like our brain blanked.
It's okay. All right, so next problem, yeah. So listen, this whole discussion here was a response to a question, right? What's your name?
Savannah?
This is all Savannah's fault. So this is a response to Savannah's question. I'm not advocating doing it this way, all right? In fact, I would, if you would allow me, I would suggest that we should probably do like this here, because this is like, more complicated. It's easier to use the number line. But anyway.
Yeah, I got you more confused.
Okay. So this made you more confused?
Yes.
But did you get the right answer?
Yeah, I did.
For the wrong reasons?
Probably, yeah.
You don't know? All right, well, let's erase this from the record.
So, when you said you want to find the common denominator, you multiply the -2 by the x plus 2. How does that make it a common denominator? Like,
My common
it's not
denom-
two separate.
Well, the common denominator is x plus 6 here. So I had to convert, like, to get 2 to look like this.
Yeah.
You just multiply by, let me put it over here. You just multiply by x plus 6 over x plus 6 like that.
Yeah.
And then when I go to, so then I can combine them because they have the same denominator.
Okay. Thank you.
Yeah, it's okay. As is often the case in here, it's just algebra. You're like, it's just algebra. That's, well, yeah, I mean, yeah. Well, that is what we're trying to learn in here, right? Example 4. X plus 2, or perhaps remember, depending on your high school, yeah, x minus 7, less than or equal to 1. So this one is essentially a number 13 in the homework. Again, annoyingly, not comparing to 0, right? So what am I going to do? I'm going to convert it to a 0 problem. How do I do that? Just subtract 1 to the other side. And I'm going to leave a little bit of space there for me to write something. The reason I left a little space there is because I want to just, I'm going to do the algebra here. I multiply by 1 to make it have the same denominator. So like, just multiply this 1 by x minus 7 over x minus 7. I can do that, right? Well, I can do that provided x is not equal to 7. And then what do I get? I get x plus 2, careful with the parentheses here, minus parentheses x minus 7. divided by x minus 7 less than or equal to 0. I say be careful with the parentheses. It's important to distribute that minus. Yeah? So we get x plus 2 minus x plus 7 divided by x minus 7. Oh, that's a good question. I have no good answer for that. Thank you. I mean, the short answer is Jeremiah 17:9. Do you guys know Jeremiah 17:9? No. I should say what it is. That takes the fun out of it. Let's see here. Be on the same page. But someone's looking it up. No. Let's see here. So the x's cancel, right? And we get 2 plus 7, which is 9, over x minus 7. So this one turns out a little bit different than the last one, right? I think Jeremiah 17:9 is, roughly speaking, the heart is desperately wicked and deceitful above all things. Who can know it? So let's see here. So critical number is what? Yep, there's just one of them here. And so number line, put a 7 up in here. And, you know, plug in any point you like. You can plug in 0. Where's 0? It's over here, right? If I plug in 0 into this, I get 9 over minus 7, which is negative, right? So I get negative over here. If you plug in anything to the right of 7, or if you use the sign flip, however you slice it, you're going to get positive on the other side of 7. All right, so is every single problem that I'm choosing today less than? It's like the fourth problem that I have stumbled into. They're all less than problems. It's giving you it might be giving you the wrong idea that we only look for minuses in the number line. That is just a quirk of the set of examples that we have stumbled upon. All right, sometimes we use plus. Anyway, but this is less than, so we look for the minuses, right? So solution set is minus infinity to 7. Is 7 included or excluded here? Excluded, why? Okay, if we have plug in 7, it's undefined. It's got division by 0 there. So. All right. Ooh, fancy. Let's look at this one. Example 5. Here we're faced with x plus 4 times 2x plus 2 times 3x minus 9. And it says less than or equal to 0 in my homework, but I'm making it greater than 0 or equal to 0. Ha! Take that. Reject your less than or equal to. Stupid. All right. There we go. Here's a problem. So you guys tell me, what are the critical numbers? Yep.
Oh, wait, never mind.
Go for it.
It's
4?
4.
And what about this one?
2.
2. 1? Okay, so let's think through it. So what we want is we either want x plus 4 equals to 0, or we want 2x plus 2 equals to 0, or we want 3x minus 9 equal to 0. These are for critical numbers, right? For critical numbers, we want one of these equations to be true, right? So this gives me x equals to minus 4. This gives me x equals to minus 1. And this one gives me x equals to 3 if I work it out, okay? Yep.
So would those be the critical numbers?
Indeed, these right here, these are the critical numbers. So it's, remember, that we have to flip the sign. Like if there's an x plus 4 factor, that means minus 4 is the critical number, you know? And these ones are even weirder. If you've got a coefficient in front of x, that messes with things, right? Up till now, we haven't had this happen. We've had mostly, you know, x with just plain old x, plus or minus a number, right? So we didn't have to think through this. But when we've got a number multiplying the x, we have to like think about what do you have to put into the x to get that thing to be 0, right? We have to think through it. But that, anyway, there it is, critical numbers. Now we make the number line. We've got to put them in order. Which one comes first? Sure, I'll believe it. Now what do you guys want to test? Test 0? All right. Where's that in here? I guess that's between -1 and 3, right? And plug 0 into this. What do you get? You get 4 times 2 times -9, right? So that's -72. So it's negative. So we put minuses up in here. All right. And then because all of the factors are linear, none of them is in even power, we flip signs every time. So I go plus like here, plus like here, and then when I get across the -4, I flip back to minus. Now, what's the solution set? We're looking for pluses this time, right? Greater than or equal to? Do we include the critical numbers or exclude them in this case? I think we're going to include all of them because we're looking for greater than or equal to 0. Every critical number here corresponds to a 0 of the expression, right? So we include the critical numbers in this case. So we're going to go like -4 all the way over to -1, both of them included. And then our solution starts again here at 3, and it keeps going to infinity. There you go. Let me erase this offensive waste of board space up there. There you go. Example 6. So I'm going to do kind of the same thing, but I'm going to do x plus 4 squared times 2x plus 2 cubed times 3x minus 9 to the 5th power less than 0. All right. I don't think there's anything like this in your homework, but you could do this one just the same. There's one? Okay. But that one might not have powers, you know. But the point is, my point to you is you could do this problem just as easy as you can do that problem. It's really not harder. So the same red calculation here shows critical numbers are -4, -1, and 3. Because that's how we can make one of these 3 factors 0. Those are your 3 ways to do it. Right? The only way you can have the product of 3 things be 0 is if one or the other of them is 0. So those are the critical numbers. Then we can draw our number line. All right. Put our -4. We put our -1 over here. We need to test a point. So, oh, my 3. I should probably not forget about the 3, right? We can test 0. All right. I'm going to write down the steps this time for the 0, though. So x equals to 0 gives me what? It gives me 4 squared times 2 cubed times -9 to the 5th power, which is what? Actually, I don't care what this number is. The point is it positive, is it negative? It's negative, right? Because this is plus, but -9 to the 5th power is negative. So this is less than 0, so, well, fine, it's still minuses in this case, but, you know, for a slightly different reason than the last one. Now, I'm going to have a chance to really see the sign flip theorem perhaps be a little bit, it's not always just flipping signs, right? Because some of the powers here are even, some of them are not. So let's see here. At 3, where is this 3 coming from? The 3 is coming from the 3x minus 9, right? And that is what? That is odd power. Therefore, sign flip theorem says we switch from minus to plus going across 3. All right? In contrast, well, actually not in contrast, and pretty much the same story here. Minus 1 corresponds to what? The 2x plus 2, right? That's what's making, minus 1 makes this one 0, right? But that's, again, to an odd power. Odd power means we flip the sign, so minus goes to plus. All right? Now, the one that's different is this x plus 4 factor, right? This time it's squared, which means that the sign doesn't change as you go across minus 4. All right? And so we stay pluses. All right? So what's the solution set to this problem? Now be careful. It's a trap. I put less than 0 here. Last one I had greater than or equal to, right?
So would it just be the negative 1 to 3 then?
Just negative 1 to 3. And are they included or excluded? Excluded. Why is that? Because we're solving just less than. We're solving strict inequality. We're not looking for zeros in this case, right? If I was to put equals to 0, then I would include it, but I didn't, so I don't. Right. Like, if you'll allow me this color coding, if I put equals here, like that, then that would change the solution set to minus 1 to 3 included. And what else? Because it's less than or equals to 0. What's equals to 0? All 3 critical numbers. So I would also have to take in union that with what's missing. I got my minus 1, I got my 3, but I'm missing minus 4. So I'd have to take the union with minus 4. But anyway. You guys doing anything exciting this weekend? Yeah, nothing? Let's see here. Let us work. All right. Yeah. So you guys remember we have a quiz when? Next Wednesday. And what are you allowed on the quiz? One sheet of paper, front and back. Can you put examples on that quiz and that paper? Yes, you can. What are you not allowed to put on the paper? I didn't really say. If you could get test answers, that would be impressive, because I don't really, publish that ahead of time. And I don't use a test generator either, so, Yeah, I try to make my tests fresh. And yeah, you have to use a scientific calculator, no graphing calculators, no phone calculators, no friends calculators. All right. All right. Let's see here. Example 7. Suppose we're up against 5 times the absolute value of x minus 4 is greater than 10. How do you solve this thing? Yep.
Would you subtract the 10?
Subtract the 10. Well, you can leave it over there. Yeah, I see why you would say that, right? Because I've just been in this diatribe. Make everything put to 0 except when you don't, right? And when you don't is the absolute value problems. Yep. Divide by 5. But Savannah, that is actually a very reasonable thing to say given my earlier comments today. And so my earlier comments should be qualified. We don't necessarily want to make it compared to 0 for absolute value. For absolute value problems, we have those 2 theorems we fall back on, right? Which is that when you have greater than, what's that mean? That means that you can unwrap it as two inequalities. One, x minus 4 is less than minus 2, or x minus 4 is greater than 2, right? Falling back on what we talked about last class. And so either we have x is less than 2, or x is greater than 6. So the solution set in this problem, minus infinity to 2, unioned with 6 to infinity. Just remember, greater than for absolute value, a little bit tricky. Any questions about that? I'll do another one here. What if I had an absolute value of 3x plus 2 is less than or equal to 7, let's say. This one, right? And here, I'll make it more interesting. Let's make this 14. Ooh, and then we'll put a 2 over here. All right, so first thing, I isolate the absolute value. Divide both sides by 2, right? We get 7 here. Now, this is very different than the previous problem because this time we have less than or equal to. So this one we do as minus 7 less than or equal to 3x plus 2 less than or equal to 7. Subtract 2 across the inequality. We get minus 9 less than or equal to 3x less than or equal to 5. Divide by 3. Minus 3 less than or equal to x less than or equal to 5/3. Solution set is minus 3 included to 5/3. So you can see in this last pair of examples, again, there's a great asymmetry between greater than versus the less than problems for the absolute value inequalities. Anyway, I think I've covered pretty much every homework type that you have, and if you get stuck on something, just email me. I try to help you. Thanks, guys.